Welcome back to Programming Logic and Design, and in this chapter is Advanced Modularization Techniques. A very important chapter, if I might say, because what we do is that we focus on the mechanics of breaking down large code into standalone modules or methods. To, amongst others, else we ease debugging, and what we do is we make code reusable in other programs. Remember, code once, use everywhere. We consider various methods a programmer could use when developing an application, important aspects when passing an array to a method or creating overloaded methods, after which the focus shifts to using predefined methods. Now, in the last theme, we will investigate selected method design issues, which include implementation hiding, cohesion, coupling. This learning unit concludes with an explanation on actually what recursion is. Now, this is basically what you need to know in this entire learning unit. The important terminology, the important definitions need to accompany these. So if you're taking study notes, you can make or do mind map, you can go from here. All right, so let's begin. The first part of this chapter is the parts of a method. Before we proceed, I would like you to watch a video on how to juggle.
How to juggle 3 balls. Juggling, the noble art of jesters and fools. Here's how you can work your way up from juggling 1 ball to 3. You will need 3 balls to juggle, dexterity, and patience. Step 1. Stand in a comfortable stance with your feet shoulder-width apart and your elbows bent at about a 90-degree angle. Step 2. Start by practicing throwing 1 ball back and forth between your hands in a nice gentle arc. You want to keep your elbows in and your throws consistent, with the ball arcing at about eye level. Using beanbags when you first begin can be helpful, since they won't roll away when you drop them. Step 3. You'll probably find that your throws go awry a little at the beginning, so keep practicing until you can throw the ball back and forth with your eyes closed. Step 4. Add another ball. With 1 in each hand, throw a ball as before and, before it comes down, throw the other ball underneath it so it lands in your other hand. Practice catching both balls. As you practice, alternate starting with either hand. Step 5. Put 2 balls in your dominant hand and 1 in the opposite hand. Toss the balls just as before, but add a 3rd throw right before the 2nd ball comes down. Keep practicing until you can make 3 throws and 3 catches. Step 6. Once you're confident catching all 3 balls, add a 4th throw and catch, and a 5th one, and so on. Don't look now, but you're juggling.
All right, so some questions which you need to ask yourself. Why am I showing you on how to juggle? And we're learning about methods and parts of the method, the basics. Well, how is the skill to juggle 3 balls explained in the clip? Well, does the fact that the skill is explained as a set of processes make it easier for you to follow or to understand how it works? Or how would a programmer benefit from applying the same principle when developing applications? So if you were presented with a program that contains multiple processes or actions, how would you be able to distinguish between them? Okay, here I have a program for you, an example. What you've got to do is you've got to input a number, and that number is doubled, for instance. So how are we going to distinguish between the different processes here? All right, let's have a look at the output. We're outputting enter another number or quit to quit. And you can see we do that twice because here we initialize the number and then we alter the number. That's what happens when we work with loops, right? Okay, so we've got a process happening here. So we create a method for that doubled up process, that process that's working twice. Yeah, we input the user num. Then now we need to identify another process. Where we are doubling our number. And that process, we now make a method for that particular process too. So what we do when we modulize a program is we take a standalone program like this and we see what processes can be modularized, what multiple processes or actions are being done in this program that we could make a module out of it, that we can reuse in not only this program, but multiple programs. And you see it's standalone. Here my variable name is localized just to this method. Okay, so what is a method? A method is a program module that contains a series of statements that simply carry out a task. It is invoked or called from another program or method. So here you can see input $amount is being invoked or called over here within the program. Okay, let me ask you, how many methods can a program actually have? 1, 2, or unlimited? Yeah, of course, unlimited amount. You can make as many methods as you seem fit for your program. So each method can also be called an unlimited number of times too. All right, let me ask you an important question. In this course, would you actually differentiate a method over here from a variable? Yes, the brackets, the parentheses tell me that this is a method, and no parentheses here says that this is just a normal little variable. Okay, so what must a method include? We need a method header. Over here, line 11 here is a method header. Line 19 is a method header. It's also called the declaration or definition. You need a method body. And what is the body? This is the body here between the method header and the return statement. So what is the body? It contains the implementation, and implementation is just a fancy word for statements that carry out tasks. The method return statement, what does this do? Well, it returns the control to the calling method. Here's the calling method over here. So it returns control to the calling method in the mainline logic. All right, a special note when it comes to return statements is that it's not recommended to actually have multiple return statements. So it's got to be structured programming. One return statement equals the last one. Okay, so just use one return statement. All right, let me ask you another question. Can variables and constants be declared within a method? Yeah, of course they can. Local, declared in the method, like 20s, 10s, 5s, and 1s, those are our localized variables, or global, known to all modules. So within the mainline logic, those declarations are global. Another important way to how to define local is that these variables here are in scope. So they're recognized only within a method. All right, let me ask you a question. Which one would you prefer to use? Localized variables or global variables? Well, a lot of programmers prefer these localized variables here because the method is more portable. So I can take this entire method and just plug it into another program. And also it's less prone to error because these localized variables can be transported to another program much easier without having to redeclare variables, global variables in your other program.